So there are quite a number of redox reactions that involve processes where electrons are transferred. It turns out that combustion reactions all involve transferring electrons. So the reaction between elemental hydrogen and oxygen to produce water is an example of a redox reaction. It involves the case of the elemental hydrogen having 0 oxidation number, whereas the elemental oxygen also has a 0 oxidation number. But in the water, formally the hydrogen is +1, so the hydrogen atoms are losing electrons, and so in this case the hydrogen is involved in the oxidation, and it can be described as the reducing agent, whereas the oxygen is being reduced from 0 oxidation number to 2 minus, and in this case it is the oxidizing agent. Likewise, methane, when it undergoes a complete combustion reaction, is also a redox process. In the case of the methane, the carbon is 4 minus, whereas in the product, carbon dioxide, the oxidation number is 4 plus. So in this case, the carbon atoms are getting oxidized, and the oxygen atoms are being reduced from elemental oxygen to the oxide ion in water. Turns out that the hydrogen atoms are not changing their oxidation number. In the methane, they're formally +1 oxidation number, and in water, they're also +1. Another important example of a device that involves a redox process is the classic batteries. In the diagram that you see here, we have a certain design for a dry cell battery. And so in this case, we need to have something that will act as the negative terminal, the so-called anode, and we also need to have a cathode. In this case, this is manganese oxide. So in this particular case, the overall process involves zinc being oxidized. Zinc metal goes to zinc 2 plus and loses 2 electrons in the process. So this is the oxidation. And likewise, the process that is occurring at the cathode involves manganese 4 oxide and water, which is then being reduced to produce Mn2O3, manganese 3 oxide. So there are a number of industrially important processes that involve redox reactions. One of them is production of zinc metal, and this can be formed from zinc oxide and reducing it with elemental carbon. And so in this case, we have the reaction shown here, where the zinc is in the form of zinc oxide. The zinc oxidation number is 2 plus, and it goes to elemental zinc, which is an oxidation number of 0, so zinc is being reduced. The carbon is going from elemental carbon, which is oxidation number of 0, and forming carbon monoxide, where the carbon is 2 plus in its oxidation number. So the carbon is being oxidized. The oxygen in the zinc oxide is not really changing oxidation number. It's going from 2 minus in the zinc oxide to 2 minus in the carbon monoxide, and so it's not actually directly involved in the transfer of electrons. We also have a number of naturally occurring redox reactions that are known as corrosion reactions. classic example of this is the rusting of iron. So in this particular case, iron metal will react with elemental oxygen to form iron 3 oxide as shown here. The iron metal, which is the reactant, has a 0 oxidation number, but the iron on the product side is got an oxidation number of 3 plus. So it's losing electrons in this case, so it's being oxidized, whereas the elemental oxygen is going from a 0 oxidation number to 2 minus, so it's being reduced. And then finally, redox reactions are important in various biological processes. So for example, in order to release the energy stored in certain high energy biological molecules, the process of oxidation needs to occur, which is a process involving oxygen. And so glucose can react with elemental oxygen to undergo essentially what appears to be a combustion reaction, but this is a combustion that occurs in a very controlled way facilitated by a variety of enzymes. In the case of the oxidation numbers, in terms of writing out the oxidation numbers for glucose, carbon is in the 0 oxidation number formally, whereas in the product, the CO2 is +4, so the carbons are being oxidized. The elemental oxygen is the species that's being reduced from 0 oxidation number to the 2 minus in the water. Formally, the hydrogens which are in the glucose and the oxygen which are in the glucose are not being or not changing their oxidation numbers, and therefore not directly involved in the transfer of the electrons.